the third video. In the third video, up to 30 questions we discussed. Now we are going to continue with 31 onwards. Okay. Which of the following is correct statement? So we need to identify correct statements from the given four options. Okay. Sodium hydroxide and potassium hydroxides are strong bases. Yes. These are strong bases. Sodium hydroxide, potassium hydroxide are strong bases. Why? Because generally these two oxides are these two hydroxides are the alkalis. That means when we are going to dissolve in water, they are 100% completely ionizes and produce OH minus ions. On complete ionization, the bases which are completely ionized, they are considered as what? Strong bases, nothing but alkalis. So these are the strong bases because of completely ionized. They are undergoes into a complete ionization. Next, sodium hydroxide and KOH are alkalis. Sodium hydroxide and potassium hydroxides are alkalis. Just now we discussed because of they are completely dissolved in water. Therefore, they considered as alkalis. Now, sodium hydroxide and potassium hydroxide turn blue litmus to red. No, we know. Okay, blue litmus paper turn red in acidic media, red litmus paper turn blue in the basic media. So these two are the alkalis, means bases. In the bases, red litmus paper turns into blue, not blue litmus paper into red. So this is incorrect option. Now we come to the option D. Sodium hydroxide is known as a caustic soda. Yes, sodium hydroxide is named as what? Caustic soda. It is also common name of sodium hydroxide is what? Caustic soda. Caustic potash means potassium hydroxide. Caustic potash is the potassium hydroxide. Caustic soda is sodium hydroxide. Okay. So our options are A, B, D are correct. Now we go to the next question. Here somewhat question numbers are jumbled, reversed. Okay. What defines a neutralization reaction? What defines a neutralization reaction? Already in the previous video, we discussed that neutralization reaction is a chemical reaction in that acidic compound is reacting with the basic component and giving rise to a neutral compounds. That means what? Aqueous solutions of acids and bases are reacting together and giving rise to a neutral compounds, salt and water. That reaction is called what? Neutralization reaction. So in the neutralization reaction, simply in shortcut is given the options. What defines the neutralization reaction? We need to pick up that. So, involves an acid and base. Yes, acid base are involved in that and they neutralized. Produces salt. Yes, salt is a neutral compound produced in the neutralization reaction. Results in the formation of water. Yes, one more along with the salt, one more neutral compound is produced by the H plus and OH minus ions, that is what? Water. So results in the formation of water, that is also correct. Yields an acid. No, it is yields salts, neutral compounds, not an acid. So which are correct options regarding the neutralization reaction? A, B, C. So our options are A, B, C. Okay. Now we go to the next question. Characteristics of bases include. So, in a given four options, which are the characteristics of the bases? Okay. Now we come to first one, having slippery feel. Yes, bases are slippery in nature. A bitter taste. Bases are bitter in taste. Okay. Changing red litmus to blue. Yes. Being obtained from fruits. No. Generally, acids are obtained from fruits. Acids are obtained from fruits. Bases are not getting from the fruits. Generally, acids are obtained from fruits. Okay. So, which options are correct regarding the bases? A, B, C. Okay. Now, we go to the next. What natural source is utilized in the production of litmus? What natural source is utilized in the production of litmus? So generally in the production of litmus, which are lichens we are using. Why? Because lichens is what? Lichen is one of the composed organism composed organism. It is neither fungi or neither fungi or algae, but it is due to the symbiotic characteristic properties. It is composed organism like a fungi characteristic components and algae characteristic components. With that combination, it will be developed. That is what lichen. So lichen is generally collected and dried. The dried lichen is powdered. That powder is mixed with somewhat chemical components like ammonia, lime. This kind of chemical components are mixed with the lichen, dried powdered lichen. After then, they will be allowed to aerobic fermentation. Aerobic fermentation. When it is allowed to aerobic fermentation, it is changed into that resultant substance is changed in the blue colored substance. Then it is mixed with the chalk. Then it is again pulverized as a powder, dried and pulverized as a powder. After then going to mix with the solvents like water or ethyl alcohol. Then it is prepared as a litmus solution. Then it is impregnated with the paper. Then the resultant paper is called litmus paper as a solution, at the same time as a paper we are using. Okay, so there the lichens are used as a indicators by following the certain process. Okay, simply first of all we are drying the lichens, then pulverized into a powder. That powder is mixing with the chemical components like ammonia and lime. After then the resultant mixture is exposed to the treated to the aerobic fermentation for 2 to 3 weeks. After then it will be gives characteristic color. That compound is mixed with the chalk. Then resultant one is again powdered, and that powder is mixed with water, soluble in water or ethyl alcohol. That is the litmus solution. If it is impregnated with the paper, that is what litmus paper. In that way, we are going to prepare litmus solution and litmus paper by using the lichens. Okay. Now, we go to the 36th question. In chemical laboratories, which type of rose is utilized as an indicator? Which type of rose is utilized in chemical laboratories? Which type of rose is utilized as a indicator? Red rose, blue rose, China rose, all of this. So among the three roses are given. Which rose is used as a indicator is asking. So China rose is used as a indicator to identify the acidic and basic media. Why? Because China rose, if you take China rose, generally red in color, in acidic media, it gives dark pink or magenta color. And in basic media, it gives rise to green color. Okay, acidic media, dark pink or magenta color. In basic media, it gives rise to green color. So in that way, China rose is used to identify the media is acidic or basic. Okay. Next, we are going to give the answer for 37th question. Here also this is a comprehensive type question again. Certain salts are better known by their common names rather than by their chemical names. Okay. The common name for hydrated copper sulfate. Just now in the previous videos we discussed chemical components are having two names. Okay. Based on the chemical composition, based on the chemical properties and its behavior, a technical name is given to the chemical compound, that is called what? Chemical name. At the same time, depending on its physical appearance and its historical place where we are finding that its characteristic appearance, based on that a name is given to that, that is what common name. Okay, so elements, the chemical compounds are having two names, common name as well as chemical name. So here we need to find out the common name for the hydrated copper sulfate. So hydrated copper sulfate common name is blue vitriol. Blue vitriol, the chemical formula is CuSO4 5H2O. CuSO4 5H2O. Okay, pentahydrated copper sulfate is called blue vitriol. Green vitriol means heptahydrated ferrous sulfate. Heptahydrated ferrous sulfate. White vitriol means heptahydrated zinc sulfate. Red vitriol means cobalt 2 sulfate heptahydrate. Cobalt 7H2O. COSO4 7H2O. That means cobalt sulfate heptahydrate, otherwise heptahydrated cobalt sulfate. Okay, so the common name of blue vitriol is not the common name of pentahydrated copper sulfate is what? Blue vitriol. Okay, now these all are nothing but hydrated salts. These all are the hydrated salts. Hydrated salts means what? The given salt molecule is associated with the fixed number of water molecules. Then the resultant molecule is called hydrated molecule. That is called water of crystallization. So water of crystallization indicates what number of water molecules associated with the molecule of a salt. That is called what? Water of crystallization. Each molecule of salt is composed with a certain number of water molecules in its crystal lattice. That is called water of crystallization. The number of water molecules associated with the molecule of a salt in a crystal lattice is called water of crystallization. So here water of crystallization of copper sulfate is how much? 5. Why? Because 5 water molecules are associated with the copper sulfate. So common name is blue vitriol. Why it is named as blue vitriol? Because of it is blue in color, purely blue in color. So that is why blue vitriol. Green in color, green vitriol. White in color, white vitriol. Red in color, red vitriol. Okay. Now we go to the next question. The common name for the calcium carbonate is, the common name for the calcium carbonate is chalk, marble, limestone, all of this. All of this. The common name for calcium carbonate is what? All of this. Chalk, marble, limestone. All are the common names for the calcium carbonate. Now, next question. The common name for sodium hydrogen carbonate is, the common name for sodium hydrogen carbonate is, sodium hydrogen carbonate is nothing but what? Sodium bicarbonate. The chemical name of NaHCO3 is nothing but sodium hydrogen carbonate, otherwise sodium bicarbonate. Common name is baking soda. Common name is baking soda. So our option D is correct. So this is what? NaHCO3. NaHCO3, sodium hydrogen carbonate, otherwise sodium bicarbonate. Okay. Now 40. So matrix matching type questions. We need to correct matches for this. Citric acid. Citric acid is generally present in what? Citrus fruits. So here present in lemon. Lemon is one of the citrus fruit. Therefore option A. Turmeric indicator. Turmeric indicator gives red in color in basic solution. So option B. Metals displace hydrogen from acids and gives rise to metal salts. So option C. Metallic oxides, metallic hydroxides are basic in nature. So therefore option D. A, B, C, D. Next we go to the next match the following matrix type questions. Here organic acids and their sources are given. We need to match organic acids with their sources. Citric acid found in orange. Sorry. Citric acid is found in orange. So here A. Acetic acid found in vinegar. So option C. Oxalic acid occurs in tomatoes. Option B. Tartaric acid occurs in tamarind. Option D. A, C, B, D. Okay, these are the correct options. Now we go to the next assertion reason type questions. In this assertion is one of the sentence is given. For that sentence, a reason also given as a reason. Means why that? For that we are giving the explanation. The explanation is supporting that assertion or not. We need to identify that. Based on that, the options are given. Phenolphthalein is a synthetic indicator. Yes, phenolphthalein is a synthetic indicator. Generally, phenolphthalein, methyl orange indicators are the powdered chemicals. These powdered chemicals are again mixed with the soluble in dissolve in water and giving rise to their solutions and producing their solutions. Again, their 1 gram is mixing with the 500 ml of water. Methyl alcohol, ethyl alcohol, in the different solvents we are using to prepare this. Generally water is used. Okay, 1 gram is used. 1 gram is allowed to dissolve in 500 ml of water or in 200 ml of water. That means depending on the strength, we are preparing the different concentration of indicators. Okay, there they are allowed to dissolve in the water and ethyl alcohol. We are preparing their solutions. So phenolphthalein is a synthetic indicator. Phenolphthalein gives a pink color in alkaline solutions. Yes, it is gives pink color in alkaline solution. Basic solutions it gives pink color. In acidic solutions colorless. So here options are given. Assertion and reason both are correct, and reason is the correct reason is the correct explanation for the assertion. Here spelling that mistake is given. Correct explanation. Reason is the correct explanation for the assertion. Okay, this correct. First one is the correct option. Now we go to the next question. When hydrated salts lose their water of crystallization upon strong heating, they transform into anhydrous salts. Yes. Reason: anhydrous salts are the residue left behind after the removal of water of crystallization from water molecules from hydrated salts, causing a change in their appearance and properties. Yes. The sentence, first sentence is correct, and second sentence is giving the correct explanation for the first one. So therefore here also option A is correct. Assertion, reason both are correct, and reason is correct explanation for the assertion. Correct explanation for the assertion. How? Generally water of crystallization means what? In a crystal lattice of salts, each molecule of salt is associated with the number of water molecules, while that the salts are called hydrated salts. They contains each and every molecule in that salt contains the one certain number of water molecules that are called hydrated salts. When we are going to heat these hydrated salts, they loses the number of water molecules from that. That each and every salt molecule is loses the water molecules. That means the water of crystallization is removed from that. So that process is called removal of water of crystallization. So by removing the water molecules associated with the salt molecules, the color and appearance, everything, the properties of salt molecules are changed. So that is given as a reason. So both are correct. Now we'll discuss that. If you take hydrated copper sulfate, hydrated salt, CuSO4 5H2O. CuSO4 5H2O, it is blue in color. Hydrated copper sulfate. On heating, it loses the water molecules. It loses the water molecules and giving rise to CuSO4, anhydrous salt. Anhydrous salt means salt, it lost the water molecules. It is a normal salt. It is not contains any water molecules. This is what hydrated salts. Hydrated salts, by the process of removal of water of crystallization, they turns into anhydrous salts. Okay. So by converting hydrated salts into anhydrous salts by the following the process of removal of water of crystallization, the resultant anhydrous salts are changes their color, appearance and properties. Okay. So this is given. So option A is correct. Then we go to the #50. Carbonic acid is used in making soft drinks. Carbonic acid is used making in soft drinks. Sulfuric acid is used in car batteries. Statement type questions. They are individual. The statement type questions means both the statements are individual. They are not interlinked with each other. Okay, they separately we need to focus on each and every statement. Both are correct. One is correct. Two are correct. In that way we need to identify that. Carbonic acid is used in making soft drinks. Yes, in the preparation of soda and cool drinks we are using the carbonic acid. First statement is correct. And statement 2, sulfuric acid is used in the car batteries. Yes, this statement also correct. In sulfuric acid is generally used in the car batteries. So both the statements are correct. Option A. We need to pick up option A. Okay. So in this video, maximum questions we discussed. 20 questions we discussed. In next video, we are going to discuss remaining questions. Okay. Thank you.